Hi everyone, in this video I'm going to be talking about the valence bond theory. Now the valence bond theory was given by Hitler and London long back, but this theory is also based on the quantum mechanical model, okay, which considers orbitals to be nothing but waves, okay, which means orbitals can be represented by a wave function which is psi, and orbitals also behave like waves, okay. So what is the main feature of the wave which we consider orbitals also to exhibit? The main feature is interference, okay. What is this interference? As already discussed before, interference is nothing but the combination of waves. So basically, we can add or subtract the waves, and because we are going to use addition and subtraction as mathematical functions, we can call this linear combination of atomic orbitals. When we use the word linear, we can use functions like addition and subtraction only. We cannot use functions like multiplication or division, okay. So because we are adding and subtracting the waves together, we call it linear combination of atomic orbitals. Now how do we add or subtract the waves, okay? So when the two waves that we are talking about, okay, are in the same phase, which means the crest of the wave, the crest is this upper part, the part which goes up, okay, is called the crest, and the part which goes down is called a trough. So when the crest of one is overlapping with the crest of another, and the trough of one is overlapping with the trough of another, okay, we have two waves like this, psi 1 and psi 2. When there's a crest overlap and trough overlap, in that case we say that both the waves are in phase, okay. And when two waves which are in phase, they combine, we get a resultant wave which is having an amplitude even higher than the ones which used to combine together, and this is called a constructive interference, which means that there has been an addition which happened, okay. And this is kind of an addition of the two waves which were initially combining. The same thing can happen on a different line, which means we can have two waves which are in opposite phases to each other, which means they are out of phase, okay. Out of phase happens when the crest of one, okay, is overlapping with the trough of another. When this kind of situation happens, we have a kind of subtraction which happens, okay, between the two waves, and what we get is a resultant wave which is having an amplitude even smaller than the combining waves, and this is called a linear combination in subtraction. So this is psi 1 minus psi 2, and this is psi 1 plus psi 2, okay. Since both these are addition and subtraction, both these are linear combinations only. One linear combination is resulting in a kind of constructive interference, and the other one is resulting in a destructive interference, okay. So in the same lines, on the same lines, we can combine two different orbitals. Maybe we can combine ss orbitals together, sp orbitals together. We cannot combine s and d orbital together because they are of very different energies, and we can only combine orbitals of similar energies, okay. So on the same lines, if we try to combine orbitals together thinking of them as waves, we'll start first with the ss overlap. Okay, so as already discussed, when the overlap happens along the internuclear axis, we call it as a sigma bond, okay. So this is the internuclear axis, which means we generally consider it as a z axis is the internuclear axis. Convention is this only. Now when we have two s orbitals, okay, so this is also an s orbital and this is also an s orbital. When two s orbitals combine, okay, or overlap, because since whenever there's an ss overlap, it is always going to be a sigma bond, because s is not s is basically a spherical one, okay. So it's always going to be on the internuclear axis, it's never going to be outside the internuclear axis. Now when we do an ss overlap, considering that both of them are having the same phase, it could be positive or negative, okay. In that case, we have a constructive overlap, and the resultant orbital is going to have a higher electron density, okay. So amplitude is something which is analogous to the electron density. So when we are combining two s orbitals which are in the same phase, the resultant wave is going to have a higher electron density, and of course two nucleuses are going to be there, and this is the resultant orbital, okay. On the same lines, when we have an ss overlap, when the two combining orbitals are in the different phase, okay, one is positive and the other is negative. Please remember, this positive and negative are not charges but the phases, okay. Do not consider them as charges. So when this kind of overlap happens along the internuclear axis, what we get is a resultant wave which is out of phase, which means it is going to be something like this, okay. They're going to be repelled from each other. Kind of repulsion happens, and we have a nodal plane. A nodal plane is a plane in which there is absolutely no probability of finding any electron density. And as you can see here, we have no nodal plane, okay? But here we have one nodal plane which is formed, and this kind of orbital SS overlap is not something which is formed, and this is what we basically call anti-bonding molecular orbital, about which we are going to study in the molecular orbital theory. We can also do the same thing in case of p orbital, okay, where there's going to be a pp overlap. So when we do a pp overlap in a sigma bond, so if we want a sigma bond to be formed along the pp, along the internuclear axis, okay, so this is the internuclear axis. I'll just draw it again because it's kind of messy. So since this is the internuclear axis, this is one p orbital and this is the other p orbital, okay. Considering that the same phase is combined, this is positive, this is negative, this is positive, okay. So because positive and positive are going to combine, this is going to be a constructive interference, right? So the resultant wave is going to have a higher electron density in between this lobe, okay, and this is a bonding molecular orbital. Whereas we could have an pp overlap, okay, a sigma pp overlap rather I should say, which could have been out of phase, which means a positive one would have been interacted with the negative one, okay. And if this kind of overlap happens, we again have a kind of anti-bonding molecular orbital which is formed, which basically repel each other. We again have a nodal plane here between the two orbitals, okay, and this is the anti-bonding molecular orbital, okay. Again, when we have a pp pi bond which is formed, okay, in cases of pi bond we know that we have a sideways overlap which takes place, right? So of course it is never along the internuclear axis, that's why it is a pi bond. So when pp overlap happens, and this overlap along the pi bond is actually a in phase overlap, okay. So a positive phase is going to interact with the positive one, a negative is going to interact with the negative one. We get a resultant wave or an orbital which is having this kind of electron density, okay, positive and negative. We still have a nodal plane here, okay, but we have electron density above and below the plane. This is called the bonding molecular orbital in case of pi bond, okay. You call this as a pi. Above, you call this one as a sigma and this one as a sigma star, okay. Now, in case of pi bonds, when we have a bonding which is out of phase, okay, in case of a sideways overlap, it could be something like this: positive interacting with a negative and negative interacting with a positive. When this kind of overlap happens, which means it is out of phase, we get again something like this, okay. We have a nodal plane and there's absolutely no electron density which is found, because since these two combining orbitals are actually repelling each other, and what we get is an anti-bonding molecular orbital. We also call it as pi star, okay. So these are the interactions of various orbitals together, considering the orbitals to be wave functions. We have various linear combinations which can be formed, and all this is a part of valence bond theory. We have different theories after this which we study, just like hybridization or molecular orbital theory, which have even more explanations of the same fact. So please watch those videos also to understand this theory better. And if you have any doubts in this video, please comment that below. And thank you so much for watching.